Hello, my name is Alex, and today I will discuss a project I have done as a part of a procedural content generation module. The theme for this project was monsters. The outright idea was inspired mainly by open-world game Horizon Zero Dawn, where the main action happens thousands of years after the technogenic post-apocalypse. That in reality, robots are created for reconstructing the Earth biotope, and they follow nature rules of predator and prey. Humans, on the other hand, lost the technological advancement, so they use primitive weapons and armor obtained from the hunted robot animals. Others said that robots that simulate the animal behavior and have a potential to hunt you down is a representation of monsters, and post-apocalyptic world with previous generation left over is a good habitat for such monsters. The Outer started with a reference collection. First, the Outer saw developer GDC talks and read an art book where he found out that all the game locations were inspired by real-world locations such as Colorado Rocky Mountain National Park as a secret land or Monument Valley as the Meridian game location. After getting more context, the Outer generated AI reference images using multiple different prompts. After exploring AI and original game developer reference images, the Outer identified the main categories and key features in each to work on. The categories were terrain, robots, buildings. The terrain category included features such as having different ecotopes defined by height, slope, temperature, etc. Additionally, each ecotope had unique vegetation. Moreover, the terrain category involved the possibility of having rivers. Robots in the original Horizon game series were created and animated by observing real animals and discussing mechatronic features and how they will affect their behavior. As the Outer needs to gain skills in modeling animation and has limited time for project implementation, the Outer identified features of armor and its placement, and robots procedural animation. Finally, the building category involved the partially and fully destroyed buildings integrated into the world. For this project, the Outer used Houdini and Unreal Engine software. The Side Effects Labs package was installed in the Houdini toolset. On the side of Unreal, better features as inverse kinematics and PCG toolkit were utilized. Houdini was used in terrain generation, including splitting height map by layers that later helped implement ecotopes in Unreal. Moreover, the object scattering and river generation together with flow map bagging was also handled by the Houdini. The wave function collapse part of the building generation and formal grammar part were handled within Houdini too. Unreal Engine was used for the Fox blueprint random scattering, post-processing such as visual enhancements such as texturing, materials, correct object displacement. Additionally, partial procedural animation using inverse kinematic approach was used together with the blueprints scripting to simulate animal wandering around. This project can show the whole beauty and potential of PCG. Because the world is open and should simulate the nature, producing such a world by scattering all the objects manually would take an insane amount of human resources, especially considering different rules, such as much exist for each ecotope or between two foreign assets. For example, do not place assets close to each other or cannot be on the same height layer. Introducing new rules would mean starting from scratch and losing a lot of progress. However, PCG techniques provide a quick way to iterate over the prototypes and find references for world shapes, locations, and asset distributions through rules that designer can specify. For example, manually creating river trajectory, adjusting terrain for it, simulating the flow, and making the flow into the texture would take a good chunk of the time from the developer. Meanwhile, by utilizing PCG tools, the designer change a few parameters and see the new result. Another example is object scattering, where developers may specify the ratio of the asset and the asset variations, sometimes using variance maps. In terms of robots and creatures, procedural animations using IK can save tons of time for animators, as instead of animating each bone of the character for a particular animation, they can specify the rig rules, bone limits, bone to ignore, and results will be more believable and robust, especially the full PCG approach, when even the movement flow, such as doing a step, is done procedurally and not with the keyframes. May solve many edge cases for animations, making automated testing, integrated tests, much more accessible for such things. Finally, PCG buildings may provide a unique experience for the player while reusing the same assets. A bunch of the simple rules and a bit of random, and not forcing art designers to implement multiple variations of the same house using the asset to make it feel unique. A good example was in Marvel's Spider-Man game, where developers utilized procedural animation of the whole game world and building themselves. To make it feel unique, a mixed parallax effect with multiple variation of cube maps was used to replicate their rooms inside the buildings. Moreover, the VFC approach wouldn't require level design to adjust each building after a small change to one of them, as the texture contains all the placement rules, and the VFC solve step will update the surrounding using the latest available data. As common approach, developers usually log the manual adjusted pieces so VFC cannot regenerate them, as they would be considered as root starting points. For the high field, the Outer used pre-existing high field and high field noise nodes. The Outer initially devised the simple approach of resampling the line to handle the rivers. To make it more realistic, the Outer made the river avoid the mountains and go around them by utilizing the gradient of the high field. Then the Outer projected to the high field to get the actual shape of the river at that height. In the later stage of the project, Outer found a practical talk from Guerrilla Games senior specialist artist Ben Shrivers, who talks about their river setup and how it was done in Houdini. On that point, as most of procedural river stuff was done, the Outer decided only to adapt the improvement for the river to flow down by utilizing Python script and the concept of erosion inside. After getting the river trajectory, the Outer implemented that the height map slope influences the river's width using a mask. The Outer utilized volume wrangle to modify the height map mask value. Then Outer utilized the erosion simulation to add more buildability to the river and the terrain itself. Afterwards, the Outer converts the high field into polygon and extracts the river mesh, which will be used for a flow map. To generate the flow map, first we need to calculate the normal of each point, so when we sweep the line, we will get the correct rotation of the flow map. Back to the height map and settlement origin points. The points for them are selected only considering two parameters. The place should not be very steep and should not be part of the river. Before they are used, the Outer initializes the VFC grid for manually created texture and executes VFC on bigger scale. To eliminate small areas where buildings would be useless, the Outer devised a solution of copying the grid to points, fusing and simplifying with primitives, and measuring the polygon area. Then, to have more granular control over the number of buildings, the Outer utilized the delete node with removal percentage. Buildings were planned as procedurally generated destroyed buildings using formal grammar approach. To integrate buildings into the terrain without modeling and create a more realistic look, the Outer had an idea of running a destruction simulation in Houdini. When the Outer started working in grammar building as physics simulation, the Outer faced an issue of needing more documentation. After some experimenting, Outer found out that Unreal integration together with physics simulation is impossible to implement as instancing happens on a real side and objects do not exist during the physics sim. However, if Outer import the FBX models, then the materials are not applied. When Outer tried approach of baking the objects and replacing the materials later, the provided lab hardware was not able to run it. In the end, Outer just used test models and later just replaced the materials instead. On this point, the Outer faced multiple issues with the simulations, such as being very slow and memory intensive. Even up to this point, the approaches of caches worked successfully. To mitigate it, Outer separated the procedural building from main terrain generation pipeline and addressed the issue of dependencies by utilizing explicit cache approach. However, it did not solve the hardware resource limit issue, so because of the time constraint, the Outer focused on different aspects of the project, such as ecotope, asset distribution. When the Outer started developing the system for ecotopes and layers, the Outer decided to utilize only one parameter, height, and for a particular case of grass, curvature. Ultimately, the Outer split the height field into 5 layers by 20% each, a layer for grass and 2 layers for river. All the layers use the attribute instancing to distribute 3 asset families. The designer can also determine the ratio of the assets relative to the points available and specify the square distance where objects from the same layer, but not the same asset, cannot be spawned. However, it is not the best approach, as assets distributed in this way cannot fill 100% of a squared space, and hexagon are much more preferable, as mentioned in the GTC talk. The Outers of Horizon Zero Dawn use the combination of height, variant, displacement, and erosion maps. The Outer decided to take existing models of the creatures and animals using procedural features of Houdini to modify the visuals such as armor, and finally use procedural animation features of Unreal to animate them. The Outer planned to implement robots as wolves, dragons, and foxes. The main idea was to add armor pieces to the model via Houdini. The Outer decided to have 3 different armor shapes: triangle, trapezoid, and hexagon. To have the armor on specific part of a model, the Outer has utilized a group pane node and remeshing approach. The dragon had more advanced armor because it was bigger and had more places to build it in. The Outer exposed the property to specify the Unreal material for each armor piece. Additionally, to show that these creatures are machines, the Outer used an abstract shape in combination with Boolean, operator, and coil model, which resulted in a damaged-looking parts over the legs of the dragon. On this point, the Outer tried importing the models into Unreal and testing them. The models worked perfectly, and even the material setup was done correctly. However, because Houdini imports models into Unreal as static mesh, the Outer tried to export the FBX over the model, the material data being populated in runtime and was not safe in FBX, so the grid was obtained, making it impossible to have a valid skeleton for the IK rig and visuals simultaneously. To prove an understanding of procedural animation, the Outer took a model of the fox with existing texture and skeleton, added the rig controller with a few bone rig controls, and a simple blueprint responsible for wandering around the level simulating the AI. All key features of each particular component are exposed for design by making very broad toolset. The offset, seeds, and any parameters that can be modified results that can be cached for faster iterations. After each subnet exposed all the parameters, they were merged into one subnet that takes every parameter and follows the logic flow. To make the tools more designer-friendly, Outer added a Python button for full rebuild. Same as developers of Marvel, Spider-Man, Outer learned that procedural toolsets should have much less node dependency on each other to maintain the scalability and make hand outering much easier in any phases of development. For the long period of the project, the Outer had working HDA setup. However, these were abandoned due to the specific integration into Unreal and ability to use caches with the generators. Utilizing HDA would benefit production quality tool scalability and time building particular assets, especially for building physics simulation. Initially, the Outer thought that procedural river was a promising approach for quick iteration. However, more advanced testing in the later stages of the project showed that the current implementation of the river needs more granular control. The typical approach is to have some nodes the designer can control and the river automatically adjust using these. Even the Outer explored an application of building grammar and tried multiple approaches. Aesthetics can be still dramatically improved. Robot animation skeletons integrated into color for mesh can be fixed, and to have a complete and more advanced animal procedural animations. Even though the project was improved manually after making the scene and multiple post-processing enhancements were added, the visual aspects could be even better. For example, rivers might improve by having particles and foam masks.